The manipulative that I chose to do was the Coordinate Pegboard, and the standard was a 5th grade standard, and it's patterning and algebraic reasoning. And the standard says, represent problems by plotting ordered pairs and explain coordinate values of points in the first quadrant of the coordinate plane. So I chose this because I think it would be really cool to be able to move the X and Y axis, and then there's pegs that you can add in different spots. And I think this is one that, as plots and things get more complicated, you can move it around, make more quadrants. They come with rubber bands so you can plot lines and things. So for 5th grade, we only have to work with the first quadrant. So all numbers, both X and Y coordinates, would be positive. So you could actually move the X and Y axis in order to make just one large quadrant, but you could always start with the 4 just to show students what that would look like. And then you could of course tell them that this is the coordinate plane, and that the bottom left corner would be where the X and Y axis intersect, and that's the origin. So the ordered pair for that would be 0, 0. And you might do this after students have some understanding of ordered pairs. So they could be able to tell you how to find the X, how to find a Y plot point, and that moving right to left is the X-axis, moving up and down is the Y-axis. So again, questions you could ask is, what do the numbered pairs, or the numbers in an ordered pair, represent? What happens if the X-coordinate is larger than the Y-coordinate? So where might that fall on the plane, or vice versa if the Y-coordinate was larger than the X-coordinate? You could also have students with whatever activity or question you ask, they could have to explain in just a really quick sentence how they found the plot point. So if they said the ordered pair was 5, 2, they knew that they had to go 5 to the right, 2 up in order to find that exact plot point, and kind of explain how they did that. So that would be a great way to check for understanding as well. Students are able to understand how to plot points and are able to explain coordinate values within the first quadrant of the plane when using this pegboard thing. So you could play a game, like one person plots 5 points and the other person has to write down the ordered pairs on the plot given. Okay, so if I was one student, I could say I want to plot here, and that student doesn't really have to think about it too much. You could have one over here, maybe put one right next to that one. You could do one over here, maybe one over here, however many points that you want to do. And then the other student would have to come in and say, okay, well, this is the X-axis, so I know the X-coordinate is 1. And then you would just go up 1, so I know that this point would be 1, 1, write down that ordered pair, and then so on. So you go 1, 2 on the X-axis, and then 1, 2, 3, 4, 5, 6, 7, 8, so 2, 8. Our third point, you would go 1, 2, 3, 4, 5 on the X-axis, 1, 2, 3 on the Y-axis, so 5, 3. And then this one's right next door, so we could say 6, 3. And our fifth point, we're saying 7, 8, 9, 10, 11 on the X-axis, and 1, 2, 3, 4, 5, 6, 7, 8 on the Y-axis. So that would be 11, 8. They would write this down. They could take turns going like that. It would be a really simple game, but one that has a lot of meaning for students. You could also have real-world examples or just little scenarios that they could work with so that they can see how coordinate systems can be used in everyday life. Students would have a more tangible way to understand the concept. So scenarios like designing something or just navigating a map maybe would make the learning a lot more meaningful, and they would have visual cues for that, and it would help with their concept understanding and also procedural fluency. So maybe an example would be that you and your classmates are in charge of designing a new playground. And so maybe you're given a list of where the playground equipment has to go at specific locations. So maybe they tell you that the swings have to go at 3, 4. So then the students would be able to say, okay, well, go 3 on the x-axis, and then 1, 2, 3, 4 on the y-axis. So these are the swings on our playground. And then the slide maybe is at 6, 2. So we say 1, 2, 3, 4, 5, 6, 1, 2. So that's where our slide would go. And then maybe they have a sandbox. So they would say maybe 2, 5. So 1, 2, 1, 2, 3, 4, 5. Maybe put a little more space between our slides and sandbox, but that's okay. And then you could keep going with that example. Or maybe another example is that all of your students are truck drivers. So maybe you have a certain amount of stops to make. So you could give them 4 stops, and their company gives them a map with coordinates on it to track the route. And they need to plot each of the stops to decide what the best route would be to take and how they could get the most direct route to each stop. So you could give them stops, maybe different places they have to go. You could be specific with it, or just say stop 1 is at 1, 2, and that's, 1, 2. That would be stop number 1. Stop 2, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7 is our stop 2, would be 4, 7. You could even have students like pick the plots, and the other student has to write down the ordered pairs, and then they could decide. But either way, you would have whatever your stops are, and they can decide if this is where they're starting, what's the best way that they need to go and come back to their stop, what would be the most direct route to take. Another example could be like movie theater seating. So maybe the seats at the movie theater is like a seating chart on a grid, and each seat is numbered with a coordinate. So you could have the students plot coordinates of available seats to find the best spot. After they do that, you could have a discussion about which seats are closer to the screen, which ones are farther away, how did the different coordinates affect those. And you could even say, like, add more to it and say, like, what would be the best seat at the center of the theater? What would that look like? Make them pick their own available seats, however that would work. So there's a lot of ways that you could use the Coordinate Pegboard, and it's a pretty simple tool to use. Like I said, it can go up in grades. You have things like rubber bands to stretch across the points. And yeah, this is just a really simple one that you can switch around. Again, you can move these to make different quadrants and all that.